Welcome to Practical AI, everybody. My name's Jeff Northrup. I'm with Peter Lynn. Today we wanted to talk about having courage to try crazy things. Peter, we have this little panel discussion that happened with Fei Li and Jeff Hinton. And why don't you just recap a little bit of sort of Fei's crazy thing or crazy idea that she tried and what that meant to the industry.
Yeah. So Fei was the creator of ImageNet, which was kind of the turning point for object recognition and computer vision research. For many years, people kept thinking of algorithms and implementing them. And there was this whole other camp, the neural network camp, and Jeff Hinton started doing neural network stuff in the late 70s. So he's been doing this for like 30, 40 years. But it wasn't until ImageNet contest that all of a sudden people are like, oh my God, neural networks can do better.
And why was her, idea so revolutionary, or why was it so controversial, maybe?
Well, it's controversial because back then there was this huge bias in the whole industry with universities, journals, conferences, where if you had done research with neural networks, or if you were trying to build large data sets, people would say, no, 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 don't do that. And the reason is because all the money and funding was towards other stuff. And it was really hard to get funding for building large data sets. And it was really hard to get funding for neural network research. In fact, in the US and in the UK, it just dried up. When that happened, Jeff Hinton went to Canada because Canada was the last place that was still funding neural network research.
Well, so I mean, today it sounds absurd, right? I mean, the the data and the quantity of data is everything, really, to AI right now. So it doesn't seem, you know, like a real story. But what I'm hearing is that it was a pretty big step for her to kind of go out on a limb that we can't even imagine today, right? It's like the whole tree is is that limb right now.
Yeah, and actually back then the largest training data sets was like CFAR 10, a bunch of smaller ones that had like 60,000, 100,000 images. And when Fei was building ImageNet, they wanted millions. The early version had 22 million images. And people were like, no, that's too big, Fei. Like, we can't use it because we don't have enough hardware and it'll take like weeks or months to train it because like it's 22 million images.
So what's the lesson there? What's the lesson there for us with what Fei did?
Well, Fei had the intuition to know that, okay, I think data is important. Whether it's handwritten algorithms or through neural networks, data was the thing that was going to get you to that breakthrough point. And her intuition was right because prior to ImageNet, everyone was struggling with just writing stuff. And neural networks couldn't prove that they were better because the data sets were too small.
So what's an example? So I mean, obviously, we would encourage people to try stuff that's maybe off the map a little bit, right? What's an
Yeah.
example of something that you've done in this space that challenged a little bit of the conventional story or the conventional wisdom?
So the most obvious one is I don't have access to a cloud full of A100s, H100s, because like universities don't even have that. Right. Then the question becomes, what can you do in your own environment? Like I have my own little lab that I built with NVIDIA video cards, and I have two MacBooks. And then the question becomes, what can you do? What crazy thing can you do to learn and to push the edges? So what I did was I looked at Kaggle competitions, and most of them start with a base model. You either go download ResNet, MobileNet, DenseNet, AlexNet, whatever. You go download one of the pre-trained ones, and then you just tack on layers and you train. And so every contest on Kaggle goes down that path of like download pre-trained model, modify it, train it. So maybe like you train one for 2 classes out of the 20 or 50, and you train another one, and then you do an ensemble so that you get the best results because you've fine-tuned different models for different things. So that was kind of the old approach. Now the new approach is just build one gigantic GPT like multimodal model, and then it can do all this stuff without training 8 different ones. But like, who can afford to train a multimodal model with video, images, and text? It's Amazon. Yeah.
There's only
It's,
5, right, Peter?
yeah. Yeah.
Google, Tesla, yeah, and so on, right?
Yeah. Like in that panel, Feifei was complaining like no university in the US today can train a GPT. They don't have the resources. So she was pushing for like someone asked them at the end in the QA section, how do we support this work? And her response was, well, donate donate video cards.
Now, I know you're still kind of in the middle of this, but with the Kaggle competitions and this downloading of like TensorFlow standard base model and then modifying it, essentially what you're doing is adding layers to it. It's almost like adding more layers of frosting on the cake. You're not going inside the cake and figuring out like the new ingredients, right?
Well, you can. So you can download the base model and set modify weights or update weights to true or false. Most people just do false because the idea is Google has spent months training this base model, so you don't need to change it. You can just add additional stuff. But that doesn't always work. So my experiment was, well, let me train a really small model with only 15 layers, and let me run it for only 40 epochs and see which one does better. And so in my experiments, my smaller model with only like one of them is only a 500,000 weights versus ResNet is like 23 million. It does better in 40 epochs than ResNet using transfer learning.
And okay, so that's really cool. So how did you do that? I
So I
mean,
did that by one saying, I've got a limited amount of hardware. What can I do? What crazy idea can I try?
right.
And then I looked at the models. I looked at what those models, the layer configurations were. I figured out what can I do on my system. I trained it, and then I compared the weights between the epochs to try to understand, like, okay, the loss is going crazy. Why is it going crazy? And then I would go in and I wrote a script to tweak all those weights, which is a crazy idea. Like no one, if you look at the literature, no one says manually changing weights is a good idea. But what I found was like I could go in, I could compare epochs and go, hey, epoch 12 was really good, but then performance accuracy went down and loss just skyrocketed to the moon. So let me compare the two. Let me see what changed. And let me adjust the weight so that the loss goes back to normal. And to my surprise, it worked.
Well, that's awesome. And like we said last video or last time we chatted, necessity is the mother of all invention. And you know, you're forced to work with what you have. And in this case, if you had unlimited resources, you would have no motivation or need
Right.
to solve a problem a different way.
Right. If I looked at Facebook or Google, I would have access to basically unlimited. I mean, there are limits, obviously, but like you could go up and say, all right, I want this much compute to train this model, and you'll get it. It doesn't cost you anything. Like it doesn't matter to you that it would cost 40K to train it for a day because Google has it. They want you to use it and you use it.
Yeah, that's great. Well, it's such a lesson to everybody, right? problem solving, critical thinking, working with what you have to learn and advance. You have to take some risks, and you have to do stuff that people say you can't do,
Right.
and stuff that maybe no one would think to do.
Yeah, because if no one was courageous enough to do the crazy things, if Jeff Hinton had listened in the 70s to his advisor and said, "Yeah, my advisor's right, I should work on a network," and just given up, we may not be where we're at today. If Feifei had listened to her advisors and realized, "Oh yeah, I'm not going to get tenure if I do this thing," and given up, we would be where we're at today.
Well, the word that stood out for me in that conversation with Feifei is when she kept using the word audacious.
Yeah.
That she had to do something audacious. She had to be audacious, and I think it's a great word because it's bold, but it's not like reckless, right?
Right.
And yeah, the world of AI advanced a lot with her audacity.
Oh yeah. Yep.
And, it's a good reminder to all of us to be audacious at times and challenge the norm.
Yeah, I mean, it's not easy. I mean, doing what people think is crazy takes courage, and you have to buckle up your belt and jump into the river and then swim upriver.
Well, we're excited to have more conversations about the success you've had with manually changing weights and the results you've shown. In the meantime, we'll encourage all of our users to be audacious in your learning and challenge the norms. Thanks for watching another episode of Practical AI. Please like, subscribe, share, and we'll keep bringing new content. Take care, everybody.